Hi, this is Jonathan Zong. I'm excited to present to you today on our work on Umwelt, which is a system that enables accessible structured editing of multimodal data representations. And I want to start this presentation off with a bit of a provocation. And the question I want to ask is access enough? What do I mean by that? So what I mean is that often work in accessible data visualization is about making existing charts more accessible, but that's not always enough. For blind and low vision or BLV people to equally participate in data analysis, they must not only be able to consume data representations created by others, but we also want to be empowering people to create their own custom representations. And why might this matter, right? So when we talk to expert data analysts who are blind professionals, they said things like, I want to participate meaningfully in a discussion at work and not seem clueless. Or, as the only blind person on a team, consistently being the only person who can't comment on a topic can affect promotions and work opportunities. And one person said, am I going to depend on collaborators to do all the analysis, or am I going to keep trying to find ways to do it myself? So the goal of our work here with Umwelt is to answer this question of how do we empower screen reader users to create their own interactive data representation so they can contribute to or even lead some of these data-driven discussions. The problem that we encountered when we started tackling this question is that existing authoring tools that are accessible to screen reader users tend to center visual specification. So what I mean by that is that the current tools often require an existing visualization to convert into a non-visual format, or require you to make that visualization first before giving you the non-visual output. Some examples of this are HighChart Sonification Studio and SAS Graphics Accelerator, which are both fantastic tools but kind of share this limitation. So what are the consequences of this vision centrism in authoring tools, right? Well, one consequence is that blind and low vision users must specify their intended non-visual designs in visual terms. And this can create additional difficulty in the authoring process. If we think about the idea of the gulf of execution from HCI theory, there's a gap between how users are thinking about what they want and the way that they're able to express it in the interface. Another consequence of vision centrism is that not all non-visual designs can be expressed in terms of an analogous visualization. So what I mean by this is that if you have to create a visualization to get a non-visual output like a sonification, you can only make the sonifications that also map onto a visualization. So in this way, visual-centric systems have limited expressivity. And you can kind of see this in HighChart Sonification Studio, where most of the examples tend to stick to a few types of charts. Most of the examples are line charts, for example, or bar charts. With SAS Graphics Accelerator, there's a disclaimer in the documentation that there's many types of charts that can be described with the tool but cannot be explored using sonification because they don't exactly have a one-to-one mapping across these two very different modalities. And so our contribution here with this project is an accessible authoring tool that decenters the visual modality. And concretely, what we've designed here is this web-based editing interface where there's an editor on the left side and a multimodal viewer on the right side that includes visualization, a structured textual description, and sonification. And while, of course, everyone can use this tool, it was designed from the very beginning with screen reader use in mind. So I'm going to walk you through a simple example of how to author a multimodal representation in this tool that kind of demonstrates one of the key ideas, which is decoupled authoring of modalities. When I load up a dataset in the editor, let's say I'm using this penguins dataset, it shows me all the fields that are present in the data. And without having to do anything, by default, the viewer is displaying a structured textual description that describes all 7 of these fields that are present. And you'll notice that this textual description doesn't really make reference to any visual concepts. It's describing a data set and it's talking about groupings by field. Now let's say I want to start by just examining one of these 7 fields for now. So I'm going to uncheck all the fields except for the beak length field. And when I do that, the output in the viewer updates to reflect that edit. So Now the textual description is only grouping the data on the beak length field because that's what's selected. Now let's say I want to keep editing and I want to add an encoding for volume to this beak length field that I've selected. So I can just go to the part of the editor under the field beak length, add this volume encoding, and that will give me the following output that includes the sonification. And I can just play this example for you here right now.
30, 35, 40, 45, 50, 55.
As you can hear in that example, it goes through the increments of values of beak length, and it's mapping that value to volume as we specified in the editor. So if we pause for a second here, I want to point out that now we have a structured textual description and we have a sonification, and we never had to specify a visualization to create these things. So this is something that wouldn't really be possible in a lot of other tools. Let's say we want to add to what we've just done, and we actually do want to maybe have a visualization to go with these text and sonification representations. I can go back to the editor and add an X encoding to beak length, maybe throw in the species field and map that to color. And then after doing that, I would end up with something that looks like this, where we've got a point chart of all the values of beak length to go along with the other two representations. And you'll notice that now that we have the visualization, the textual description has updated to incorporate some of that visual information. So the description now talks about a point chart, it talks about the x-axis and the legend, but none of that was required to get a textual description of the data. Now, switching gears a little bit, I'm going to show you another example of one of the nice benefits of decoupling the authoring process of the other modalities away from the visualization. So here I have, a scatter plot of that same penguins data, and I'm going to play you this sonification that goes along with this data.
2,700, 3,000, 4,000, 5,000, 6,000, 170, 180, 190, 200, 210, 220, 230.
So what I want to point out here is that the sonification actually diverges from the visualization. There are things specified in the sonification that are not specified by the visualization. Namely, the sonification has binning and it has an aggregation, the mean, and none of that is in the visualization. Actually, if you think about what the corresponding visualization would be of the sonification that I just played, it would look like these two bar charts. One has the y-axis bins and averages of the x-axis value, and one has the x-axis bin and averages of the y-axis value. And these correspond to what that sonification was conveying. So it was conveying the binned averages along each axis to give the user a sense of how these values are distributed in each of the two axes. The point of this example is that you don't have to design the sonification to completely try to replace or copy the visualization. Now that the authoring processes are decoupled, you can actually make multiple modalities that don't have to be redundant with one another, but can also supply new complementary information. And so just to kind of recap the implications of our approach in decentering visual specification, I think the two main points are that blind and low vision users can use Umwelt to create non-visual representations without first expressing them as a visual specification. And then the second is that the expressivity of the non-visual designs is not really constrained by the visual specification in the same way that they would be in other tools. Now, to talk about the methods we used as we were kind of undertaking this project, this research involved about a year of co-design led by me and my co-author, Daniel Hajas. And Daniel is a blind researcher with relevant HCI expertise. And together we were going through multiple prototypes of this system. And we did this through frequent Zoom and email reflections where we talked about what worked and what didn't between all these different approaches that we tried. And just to kind of give you a preview of some of the things we learned through this process, we go into a lot more detail about this in the paper, but one of the really interesting things that came up was this idea of field versus encoding-oriented editing. And if you see on the screen, we have these two different ideas for how to organize the editor. So one is kind of field-oriented, where you can start with a field and control all three modalities at once from that field. And on the right, there's another version where you scope to a specific modality like visualization, and you assign fields to the encodings that are available for that modality. And there's a lot of interesting trade-offs between these two options that are both available in the system. Another really interesting thing we go into more in the paper is the idea of default specification heuristics. So in a multimodal system, sometimes you're like specifying 3 times as much stuff, right? Because there's 3 different output modalities. The idea of the default specification heuristics is to think for each modality based on the kind of semantics and structure of the data set, what sensible default representations might be. And this is kind of very well understood in visualization, and we've proposed some ways to think about this in sonification and textual structures as well. And I just want to kind of show our example gallery here, which includes a lot of different example data sets with different kind of visual forms, but also different kinds of sonification and textual structure compositions. And you can read more about that in the paper as well. And finally, we had this really great evaluation with 5 expert BLV users. And some of the highlights from these conversations were about how multimodal representations facilitate communication between people who rely on different senses. So one of our participants was talking about how, when they were exploring the textual structure, their selection in the text was also being visually highlighted in the visualization. And that was something that they thought would help collaborators kind of get on the same page and also help them know where I'm looking with the screen reader. Another interesting idea was that analysts move between task and representation-based ways of thinking at different parts of their analysis process. So looking at an example with that penguin data, one analyst kind of initially said that they wanted to know something about what species are on which island and whatnot. And as they were messing around and making representations, they then shifted over to kind of articulating their goal more in terms of the representation they were trying to create rather than the task they were trying to accomplish. So then they were like, I want a bar chart with, island on the x-axis, etc. And being able to support both of those ways of thinking, I think, is really valuable in a system like this. As always, check the paper for more interesting qualitative tidbits. And so I'm really excited to kind of keep thinking about what we might continue to do in this space. And 2 of the themes that kind of stand out to me are the idea of mixed ability collaboration that I just touched on. So there's this idea that these shared representations and interactions are maybe useful for helping blind and low vision folks communicate results to their sighted colleagues. Can future iterations of Umwelt kind of support multi-user collaborative analysis where, blind and sighted colleagues are both participating in analysis at the same time? And then I think something we really want to kind of think about is, the idea of these modality differences and complementary modalities, and think about decentering vision even further in the design of our representations. So when we think about current approaches to tactile charts, for example, they're often just prioritizing fidelity to like what the visualization looks like. But of course, vision and touch work very differently. And so there's this question of, how can we design tactile first representations that don't really need to convey what the chart looks like, but can maybe be more effective at conveying the data itself instead. And so with that, thank you, and I look forward to further discussions about this work.